In this video, and probably one more, I'm going to explore the different concepts we've talked about and use them in Excel. Let's talk first about a simple future value. Simple future value problems are the nature of, if I have money today, or I put money in, how much money will I have in the future? So let's take a look at that. Let's suppose we had the instance. I'm going to add a couple things in here. We had the instance of somebody who is saving $5 a day for the next 30 years. How much money will they have? Well, let's calculate that. So we want to know the future value, equals future value of the rate. Let's say the rate is, let's assume they can make 9% on their money as a decimal. But they're doing it every day, so this is going to compound. So divided by 365 days. The number of periods is going to be, well, I said 30 years, but every day they're putting that money in. So the period is 365 days. And the payment is wrong place. The payment is $5. Let's take a look at what they'll have. $281,000. Right? That's what they're getting. Now, a couple things about this. Let's go back to the formula. If I go back to the formula, I probably want to make the payments negative, because I'm putting money in. Let's just see what that does. That turns our equation positive. You'll see. And the other thing to note, okay, is we did this 365 days. If we did it once a month, we divide it by 12 and then multiply this by 12. So we put $5 in every day for this period of time. Now, let's keep that up there for you. Okay. When you do this on your homework or on you're in exam, here's what I want you to do. You've got to use the round function. Boy, can they learn to type? Now, you can just point at the value like this and put a 4 in there, round to 4, and then we'll do that. Alternatively, you can take this whole equation here, and I'm going to edit it, and I can put the round around it. That sounds funny. I can put the round around it, comma, 4. And that will work as well. So although I'm going to work these problems here, I'm not going to put the round in each of these as I do them. When you do the exam and when you do your homeworks, I do want you to continue to use the round function. Okay? And again, you can point it, I guess I didn't do this one. So you can see it that way too. So you can either point at some value. This has been A1 actually. You can either point at their calculation or you can put the calculation inside. I don't care, but I do care you use the round function. All right, so that's a simple future value. What happens if I say, well, I'm going to win the lottery and they're going to pay me $50,000 a year for 20 years. What's that worth? Well, let's take a look. It's equal to, whenever we say what it's worth, we want to know the present value. So we'll say present value of the rate. Again, we'll do 7% for the heck of it. Number of periods, we'll get paid once a year, 20,000. And there's no future value. And that's worth $211,000. Now, again, if I really wanted to do this right, well, actually, I'm getting that. So I'd be willing to pay $211,000 to get those payments of $20,000 a year for 20 years. Let's suppose I want to know, I want $100,000 in 10 years. How much money do I have to put in each year to get $100,000 in 10 years? Now we're going to use the payment function. So I want to know, what I don't know is how much I put in. So that's the payment. Let's use 7% again. I said 10 years. I have no money to start with, so I'm going to put a 0 in there. Don't forget that. And in the future, I want to get $100,000. I have to put in $7,000 a year. Remember, negative as you put them in. Okay. Again, if I made that a negative, this would come out positive. You could also put a negative sign in the beginning here. That would turn it to positive. Let's try working another one. Let's do a mortgage. What kind of mortgage can we afford? What kind of mortgage can we afford? So that would be in other words, how big a mortgage could we get? So I want to get some money. So that would equal the present value of, and let's say our mortgage we can get at 4%. It's a 30-year, but we're going to do this mortgage in monthly payments. So now we'll divide it by 12. And what triggered that was when I was about to do the number of periods. It's a 30-year mortgage, but it's 12 periods. The payment, let's suppose we can afford to pay, I don't know, $2,000 a month. And the future value will be future value of this is I'm not going to have to pay anything in the future. So let's put it in 0. But remember, I'm talking about payments here. So I'm going to put a negative here because I'm paying that money out. So I can afford a $400,000 mortgage. Again, I encourage you, when you do these things, to take a look. If you came out with something like a $5 million or $29, you know you've not calculated something correctly. Now we can do these mortgage things and change the rate and calculate for the rate. We can calculate for the present value, which or the payment. We could calculate that. Remember to use positives and negative numbers in this. And also remember to divide it by 12s or the times 12s when you do this. Let's do a capital asset pricing model. Let's suppose the risk-free rate of return, capital asset pricing model, we want to know the required rate of return, expected rate of return, and that's equal to the risk-free rate of return. So let's say 2% plus the beta. Let's suppose we've got something that's fairly risky, so it's 1.3, a beta of 1.3 times, let's suppose we expect the market to be returning 7%. Remember, always decimals. And the risk-free rate of return we said was 0.02. So we can get a expected rate of return or required rate of return of 8.5%. Don't forget to do the round functions when you do this. Okay, I'll continue and do a few more in the next video.